Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss a very interesting and very important topic of a differential equation that is known as a simultaneous linear differential equations. Simultaneous. The meaning of simultaneous means more than one member comes in any place. More than one member. Simultaneous. So this is the meaning of simultaneous. So in this differential equation also comes more than one variable in a differential equation. More than one variable. Both are independent variable which are dependent on one independent variable. So here today we want to discuss in detail about the simultaneous linear differential equation. How we can solve simultaneous linear differential equation, what is the definition of simultaneous linear differential equation. So one by one we discuss in detail in this lecture. Topic name is simultaneous linear differential equations. Type of the simultaneous linear differential equation given as follows. What is type? So simultaneous linear differential equation. Definition is given in the name of simultaneous linear differential equation. So what is definition? Simultaneous. More than one variable occurs in our differential equation. More than one variable which are dependent variable that are occurs in our given differential equation, which are dependent only one single independent variable t. So here we give one example, dx over dt. Here x is dependent variable and t is independent variable. X is dependent on t. And next variable is y. Y is also dependent variable. Y is dependent on t. So in equation 1, there are more than one variable, means there are two variables. Both variables are dependent variable x and y, which are occurs in equation 1. Simultaneous. X and y comes in simultaneous in equation 1. Now in equation 2, this equation 1. And in right hand side, there is some function of t that is known as a phi t. Phi t is some function of t in right hand side of the given differential equation. Next equation second, dy over dt. Here is y. Y is dependent variable and t is independent variable. Y is dependent on t. Plus 2y. Here is 2x. Here is 2x. So x is dependent variable also. So in equation 2, there are also occurs simultaneous two variable y and x. Y and x are dependent variable which are dependent on t. And in right hand side is some function of t. Here next phi t is e to the power t here. So here two equations are given here. Why two differential equations are given in our question? Because here two dependent variables are there. So if two dependent variable, then we want two differential equation. Only if single differential equation is given in our question and two dependent variable in our equation, then we cannot find the solution of the differential equation. We cannot find the value of x and y. But two variables, dependent variables x and y is given in our question, and two differential equation is given in our question, then we can solve the equation 1 and 2 and we find the value of x and y dependent variable. So this is the important, this is the example of simultaneous linear differential equation. Here d over dt means differentiating with respect to t, and that is represented by capital D. Differentiating with respect to t is represented by capital D. Capital D is differential operator, ordinary differential operator. Capital D is ordinary differential operator. This is ordinary differential operator, ODO. If this operator D occurs in any differential equation, that differential equation is known as a ODE, ordinary differential equation. That is known as a ODE. Okay. So here d over dt differential with respect to t, because in our equation, both equations 1 and 2, there is only one single independent variable. In any differential, there is only one single independent variable, that is known as a ordinary differential equation. But in our differential equation, there are more than one dependent variable. So we can say that this differential equation is known as a simultaneous linear differential equation. So in simultaneous linear differential equation in our question, there must be given two differential equations. Then we can find the solution of 1 and 2. So here x and y are independent variable on t, and t is independent variable in our question. So now definition of simultaneous linear differential equation. What is definition? How we can define a simultaneous differential equation in detail? In a differential equation, we see that in a differential equation, there are more than one dependent variables. More than one. More than one means two. Minimum two variables are there. So two variables. In our syllabus, there are only two dependent variable linear differential equation. In our syllabus, the simultaneous linear differential equation has only two dependent variable, not three dependent variable. If there are three dependent variables, then we want three differential equation. So that is very typical question. So here given only two dependent variables and only one independent variable. But dependent variable are dependent on a single independent variable. We know that two dependent variables are dependent on a single independent variable t. So in given the type of equation 1, x and y are two dependent variables. In last example, we have seen that there are two dependent variables, x and y, two dependent variables, and only one independent variable t. So here we see that x is some function of t, because x is differentiating with respect to t, and y is also some function of t, because y also in our differential equation differentiating with respect to t, dy upon dt, dy over dt, and dx over dt. X differentiating with respect to t, y is differentiating with respect to t. So x and y both are variables which are dependent on t. So dependent variable, x and y both are dependent variable in our question. Problem 2 based on simultaneous linear differential equation is given as follows. In last lecture, we have already discussed one problem on simultaneous linear differential equation. What is the change the problem? In last problem, when right hand side is some function of t, in our given simultaneous linear differential equation, right hand side is some function of t. But in last question, right hand side is 0. Right hand side function of t is given is 0 in our question, last question. But here Here some function of t here. Here is phi t. Phi t is e to the power t. First equation. Next equation, phi t is e to the power 5t. But last question, phi t is 0. So we have discussed problem first in detail when phi t 0. Last problem, phi t is 0. But in this problem, phi t is not 0. In this problem, phi t is not 0. So we discussed the problem second when phi t is given in our question. So what is question? Dx over dt plus 5x and plus y. Here two variables are come here, dependent variable. X differentiating with respect to t, so x dependent variable. T is independent variable. And y is dependent variable. E to the power t is some function of t, that is phi t. This equation 1. Equation 2, dy dt plus x and plus 5 by dy dt. dy dt, y differentiating with respect to t here. So y is dependent variable, dependent on t. T is independent variable. And in right hand side is e to the power 5t. In right hand side of equation 2, e to the power 5t. E to the power 5t is some function of t. So in this question, right hand side phi t is given. But we have discussed last problem. In that problem, phi t is 0. Last problem we have discussed phi t is 0. When phi t is 0, then we cannot find particular integral. So in last question, we find only complementary function. Particular integral is 0 in last question. But in this question, phi t is given. So pi is given. So here we find both solution, complementary function and particular integral, because q is given here. Phi t is given here in our question. Equation 1 and 2 are ordinary simultaneous linear differential equation. These 1 and 2 ordinary. Ordinary means there is only one independent variable. So we can say that this differential equation is known as an ordinary differential equation. But here more than one dependent variable in our differential equation 1 and 2. So we can say that equation 1 and 2 known as a simultaneous linear differential equation. Solution start. How we can solve this equation? So we discuss here procedure to solve the simultaneous linear differential equation in detail. So we writing here question first. Dx over dt plus 5x plus y equal to e to the power t. This is equation 1. Next is dy over dt plus x plus 5 by equal to e to the power 5t. This is equation 2, where we see that differentiating with respect to t is d. D over dt is here capital D. This is ordinary derivative. This is ordinary derivative. This is ordinary derivative. In above problem, we see that in LHS, left hand side, we see that in left hand side, x is some function of t in equation 1. Dx over dt, differentiation of x with respect to t. So x is some function of t here. And y also some function of t, because dy dt in second equation. Here also y differentiating with respect to t. It means y is also some function of t. And in RHS, we see that some function of t here RHS. RHS is in equation first, e to the power t. In equation second, e to the power 5t. So in both equation 1 and 2, in RHS, we have some function of t, phi t, that is known as a phi t. So here phi t is given. In our question, phi t is given. Phi t is given. Okay. Phi t is given here. Here both dependent variables occurs. In our equation 1 and 2, both dependent variable x and y occurs. Each equation simultaneously dependent on t. In both equation, there is only one independent variable t, equation 1 and equation 2. We will discuss here about the procedure. Now we will discuss here about the procedure. Procedure means method. How to solve simultaneous linear differential equation in detail. In detail. In detail. We will discuss here about the procedure how to solve simultaneous linear differential equation in detail. So dx over dt plus 5x plus y equal to e to the power t. This is equation 1. And dy over dt plus x plus 5y equal to e to the power 5t. This is equation 2. And d over dt differentiating with respect to t is capital D. Then equation 1 and 2 can be written in the following form of D. Equation 1 and equation 2. We can write in the form of D after putting d over dt equal to D. D over dt derivative with respect to t we can write capital D. Then equation 1 and 2 convert in this form. Here dx over dt. Dx over dt. We can write dx. And dy over dt, we can write dy. So after putting these two values in equation 1 and 2, we get this. So dx plus 5x plus y equal to e to the power t. This equation 3. Now dy in equation second, this second equation convert. First convert in this form. Second is dy. Dy over dt is dy plus x plus 5y equal to e to the power 5t. This is equation 4. After taking x common in equation 1, in these two terms, x is common and here is y common. So after taking x and y common on LHS, this is LHS. From equation 3 and 4, then we get. This is LHS, not RHS. This is LHS. Left hand side. After taking x and y common on left hand side from equation 3 and 4, then we get here d plus 5, x is common. X taking RHS common. Always x taking right hand side common. Then not taking left hand side. So d plus 5x plus y equal to e to the power t. This is 5. And x writing first because in first term is x in equation 5. So in equation 6 also first term is x plus d plus 5 by equal to e to the power 5t. This is 6. In equation 5 and 6 making x variable equal. Same in first term in equation 5 and 6 making x variable same. So here is d plus 5x. Here is only x. So here apply eliminating method. Eliminate after doing equal the term x, then cancel out the x, eliminate the x from equation. So here apply eliminating method operating y d plus 5. D plus 5 in equation 6. This is equation 6. In this equation operating y d plus 5. Then first term of 5 and 6 is equal. D plus 5 operating d plus 5 in equation 6 in each term LHS and RHS both sides operating d plus 5. We want to making first term as equal. Any x term we want to equal. So there will be no change in equation 5. 5 is no change, but in 6 operating by d plus 5. So here d plus 5. This equation 6. D plus 5 x plus d plus 5 by equal to d plus 5 e to the power 5t. Operating by this term on both sides to whole equation. So here d plus 5 x operating this d plus 5x plus d plus 5 d plus 5 multiply this to this d plus 5 ka square into y equal to operating this d into e to the power 5 plus 5 e to the power 5t. So d means here derivative. D means differentiating with respect to t here. So differentiating this e to the power d over dt of e to the power 5t, this equal to 5 e to the power 5t. So we write here 5 e to the power 5t, and this is constant 5 e to the power 5t. So now here d plus 5 into x, d plus 5, this is function x, plus d plus 5 ka whole square into y equal to 10 e to the power 5t. How we can get 10? 5 e to the power 5t, 5 e to the power 5t. So 5, 5, 10 after adding this. So we get here 10 e to the power 5t, this equation 7. We see that in equation 7 and in equation 5, 5 is no change. 6 is change. 6 convert in 7 equation after operating d plus 5 on both sides to left side and right side in each term. Then we get equation 7. So now we see that equation 5 and equation 7, first term is same. So here d plus and first term is in x of x is equal. Then subtracting equation from equation 5 minus equation 7. From equation 5 minus equation 7 of subtracting equation 7 from equation 5. So we write here this equation 5, d plus 5x plus y equal to e to the power t. Next d plus 5x, d plus 5 ka whole square y equal to 10 e to the power 5t. Okay. This equation 5, this equation 7. In both equation first term is equal. We check that first term is equal. So subtracting this. Subtracting here, subtracting. So change sign, be changing the sign, this minus, and this minus. So this term is cancel. Then we get here minus, first writing this term, minus d plus 5 ka whole square y plus y plus this y equal to first writing first writing this one, first writing minus first writing minus 10 e to the power minus 5t. Okay, no, this is correct. The e to the power t minus 10 e to the power 5t. E to the power t minus 10 e to the power 5t. Here y taken common. Y is common on left and right hand side. Y is differentiate. Y function here differentiate. So by taking right hand side common. So we get here minus d plus 5 ka square minus 1. Y equal to e to the power t minus 10 e to the power 5t. So here d plus 5 multiply by minus sign here. So d plus 5 ka whole square minus 1 into y equal to minus plus plus minus, convert this. In last result, this result is plus after multiply minus. Multiply minus 1 on both sides. Then this result is plus, this result is minus. So here multiply my minus on both sides, we get this result. This is equation 7. Simplifying equation 7, then we get. So here d plus 5 ka whole square. After expanding this whole square, then we get d square plus 10d plus 25 minus 1 y equal to 10 e to the power 5t and e to the power t here. So this is 8 equation. This is 8. This is equation 8. Now here d square plus 10d plus 24. 25 minus 1 is 24 by equal to 10 e to the power 5t minus et. This is equation 9. This is equation 9. Now equation 9 is known as a linear differential equation of second order with constant coefficient. Ultimately, we see that here we have given simultaneous linear differential equation with linear differential equation. After apply this procedure, simultaneous linear differential equation convert in a linear differential equation with constant coefficient. Then we apply here y is equal to CF plus PI method, and we can find the solution. So here linear differential equation with constant coefficient. Equation 9 can be solved by method of y is equal to CF plus PI. So here we apply formula CF plus PI, which we have discussed in detail in last lectures. But in equation 9 RHS is not 0, means Q is not 0. Q means phi t is not 0. Phi t is not 0. Phi t is some function of t. Phi t is not 0. So Pi of equation 9 is not 0. We find here Pi of equation 9. Now complete solution of equation 9. Complete solution of equation 9. Y is equal to CF plus Pi. Y is equal to complementary function plus particular integral. Because equation 9 is known as a linear differential equation of second order with constant coefficient. But Pi is not 0 because Q is not 0. Q not 0 means phi t is not 0. Then solution of equation 9 is y is equal to CF plus Pi. So what is equation 9? D square plus 10d plus 24 into y equal to, this is function of t. This is equation 9 here. This is 9 equation. So now there are two solutions of equation 9. Two solutions of equation 9. First is CF and second is Pi. So here first we find complementary function of equation 9. Finding CF of 9, CF of equation 9, putting RHS of 9 is equal to 0. Means Q is equal to 0. Then we get this equation. If we want to CF, then putting RHS equal to 0. If RHS 0, then we can find CF. So RHS is some function of t, that is phi t. So we taking here phi t equal to 0. Phi t taking equal to here 0. Then equation convert in this 10 equation. This equation 10. D square plus 10d plus 24y equal to 0. This equation 10. So now for finding CF of 10, this equation 10, CF of 10, putting d equal to m and removing y from 10. Removing y from 10. This equation 10. Then we get an auxiliary form of 10 in variable m. So we get here d equal to m. In last equation, putting d equal to m here. Here putting d equal to m. So m square plus 10m plus 24. And y is removing from our question. Then we get here m square plus 10m plus 24. This equation 11. So now equation 11, this equation 11 is an auxiliary form of 9. Equation 11 is an auxiliary form of 9. This is 11. After factorizing, after 9 after factorizing we get there. Now factorizing of equation 11, then we get here. This is 11 equation. Then we get m square. Here is 24 number. 24 is 6 4 is 24. Here is 10 number. 6 plus 4 10 number. So I am writing here 6 plus 4 m and 6 into 4 equal to 0. So m square plus 6m plus 4m plus 6 into 4 equal to 0. M is common here. So m plus 6 plus 4 common here. M plus 6. So m plus 6 is same bracket. Now here m plus 6 is common, next bracket m plus 4 equal to 0. This equation 12. So here if m plus 6 equal to 0, then m is minus 6. And if m plus 4 equal to 0, then m is minus 4. Here we see that roots of an auxiliary form are different. Roots of an auxiliary form are different because auxiliary form is factorizing, then we get m equal to minus 6 and minus 4. This is comma, minus 6 and minus 4. Formula for complementary function if roots are different. So formula here CF. CF equal to C1 e to the power m1t plus C2 e to the power m2t. M1 and M2 are roots. So M1 equal to minus 6 and M2 equal to minus 4. M1, M2 are roots here. So putting here value of M1 is minus 6 and M2 is minus 4. Then we get complementary function here. This is formula is 13. This is 13 formula. Equation 13. Now putting value of this, CF equal to C1 e to the power minus 60 plus C2 e to the power minus 40. This is equation 13. 14 equation. Okay. This is complete CF of given equation 1. Complete CF of 1. So equation 14 is the complete CF of 9. CF of 9. Complete CF of 9. This is 9 equation. Complete CF of 9. Now finding PI of equation 8. PI of equation 8, not 8, equation 9 is, what is PI of equation 9? So particular integral, we have applied this formula here. Particular integral equal to 1 upon fd into q. This is basic formula of finding particular integral. So putting value of fd. What is fd here? Fd means function in d. D square plus 10d and plus 24. This is fd. So here putting this 24. This is 24. Putting value of fd and this is q. This is 10 here. So this equation 15. Now pi equal to 10. This is 10. 10 taking out. And 1 upon d square plus 10d plus 24 e to the power 5t. E to the power 5t. This is e to the power 5t. Minus 1 upon d square plus 10d. Here is 10d. And 24 e to the power t. This equation 16. Okay. Now e to the power 80. Comparing e to the power 80 with e to the power 5t. It means a equal to 5 here. And e to the power 80 comparing with e to the power t. Then a is 1 here. Comparing, then we get a equal to 5 for first part of pi. First part means this. This is first part and this is second part. So first part putting a equal to 5. A is 5, so putting d equal to 5. And next is a is 1. This is second part of pi. So now putting a equal to 5 in first part of pi and a equal to 1 for second part of pi. So putting d equal to 5 and d equal to 1 in first part and second part. So here putting d equal to 5. So 5 ka square plus 10d 10 into 5 plus 24. Here putting d equal to 1. Here putting d equal to 1. Here putting d equal to 5. Now in last. After putting d equal to 5, 5 ka square plus 10 into 5 plus 24. 5 5 ja 25, 10 5 ja 50, 50 and 25 75 and 24 means 99. And so we write here 99. 10 upon 99, 10 is this. So 10 upon 99 e to the power 5t minus. Here putting d equal to 1. 1 ka square plus 10 into 1 and plus 20 plus 24. So 10 1 ja 10, 10 24 34 and plus 1 35. So here is 1 upon 35 e to the power t. So this is pi. This is equation 17. This is 16 equation and this equation is 17. This is 17 equation. This is complete PI of equation 9. Complete PI of equation 9. So now we get here PI. This is complete PI and CF. Now complete solution of equation 9. We have by equal to CF plus PI. This formula we apply here. So by is equal to, this is CF complementary function, and this is particular integral PI. Okay, CF plus PI. So this is equation number, what is equation? Equation here 17. So now this equation is 18. 18 equation. Okay, this is complete solution of equation of given question. We get value of y. Y is dependent variable. We get value of y in some function of t. So this is equation. This is solution of y. Now finding value of x. Finding value of x with the help of equation 2. We have already find y, but now we find out the value of x. Y equation 2. So equation 2 we see here. This equation 2 from the question. We have taken this equation 2 from our given question. How we can taking this equation? So here in this equation we see that equation 2, there is only single variable x. X is single variable that can be separate. X. So we can separate variable x. Then we have, so in equation 2 there is only single variable x. We cannot, that equation there are x in two term, more than one term. We are taking only that equation in which x is only single place. So here x is single place. That x can be separate from our question. So here x separating, x and other term taking right hand side. So e to the power 5t minus dy dt minus 5 by. This is equation 19. Okay. Now here, this is y. We find out the value of y here. This is equation 18. So now we want to dy over dt. We want the value of dy over dt. Differentiating equation 18 with respect to t, then we get dy over dt. First of all, we find the value of y. So now we want to find out the x, but in x there is dy dt. So we find out the dy dt. How we can find dy dt? Differentiating of y with respect to t. So we have equation 18. 18 is y. So differentiating 18 equation with respect to t, then we get dy dt. So here dy dt, differentiating with respect to t. Here differentiating with respect to t. So we get dy dt. Here C1 is constant. E to the power minus 6t. E to the power minus 6t d over dt, e to the power minus 6t. So this minus 6 e to the power minus 6t. This is differentiation with respect to t. So we have here C1 minus 6 e to the power minus 6t plus C2 minus 4 e to the power minus 4t plus 10 upon 19 e to the power 5t here. So differentiation e to the power 5t, 5 into e to the power 5t minus 1 upon 35. Differential of e to the power t is differential of e to the power t. So this is equation number 19. Putting value of y and dy dt in equation, what last equation is? 19. So this is 20 equation. In 19, putting value in 19. This is 19 equation. Okay. Putting in 19. Then we get here. So now here this is x equation. X is this. This is 19 equation. Now putting value of x, e to the power 5t. This is dy dt. This value from 20. We get from 20. This is 20 value. Dy dt. So I am writing here this value minus 6 c1 e to the power minus 6t minus C2 4 e to the power minus 4t plus 50. 5 10 ja 50. Here we multiply 5. 5 10 ja 50. 50 upon 99 e to the power 5t minus 1 upon 35 e to the power t and minus 5 by e. Here is 5 by e. So 5 multiply by y. Y is our solution. So we get, this is the solution. Solution get from equation 18. So here putting value, this is 18 value. So C1 e to the power minus 60 plus C2 e to the power minus 40 plus 10 upon 99 e to the power 5t minus 1 upon 35 e to the power t. So this is the value of x here. So x equal to e to the power 5t minus minus plus 6c1 e to the power 60 multiply by minus sign in each term here. Minus minus plus c2 4 e to the power minus 40 and minus plus minus 50 upon 99 e to the power 5t and minus minus plus 1 upon 35 e to the power t. Minus minus plus minus minus plus minus plus minus, this is minus, and minus minus, no, this is correct, plus. Here writing e to the power 5t minus minus plus minus minus plus minus plus minus this and minus minus plus this, correct. Now minus 5 multiply by minus 5 c1 e to the power minus 60 minus 5 c2 e to the power minus 40 minus minus plus, this is plus, minus हो गया. Here is already plus. Plus minus minus 5 10 ja 5, yeah, 5 10 ja 50. So here is 5 10 ja 50. Here is 50 and here is 5. Okay, we have multiplied by 5 in each term. 5 into this, 5 into this, 5 into this, and 5 into this. So we get this result. So now again this minus 5. Next one, x equal to e to the power 5t, c1 e to the power minus 60 minus c2 e to the power minus 40 minus, we are adding this result. This result adding here. Same. E to the power 5t, e to the power 5t and c1. Here this c1 and this c1. So this minus this here. We get c1 e to the power 60. c1 e to the power 60. Next one, this result. c2 4 or this 5c2. So here is minus c2 e to the power 40. Next one is this is 50 upon 99 minus. This is also 50 upon 99. So minus is common. Minus common, here is also 50. 50 means here 100. And next one is here. Here is minus 5. Here is 5 and here is 1. So here is plus, here is minus. So now here is 5. So here is 6 upon 35. Okay. This is 100. Now x equal to e to the power 5t, c1 e to the power minus 60 minus c2 e to the power minus 40. This is 100 upon 99. 100 upon 99. E to the power 5t and here is 6. 6 upon this 35. So here x equal to e to the power 5t. E to the power 5t, this one. This one e to the power 5t and this. So this is common. So here 1 upon 100 upon 99. Okay. 100 upon 99. e to the power 5t. This is C1, this is C2, and here is 6. This is 6. So this is 6 e to the power this t. So now here 99 minus 120. So here is minus 1 upon 99 e to the power 5t, this minus, and here is 6. This equation number 21. This is equation number 21. Okay. So now x equal to this equation number 21, and y equal to this equation number 18. So now equation 21 and equation 18. This is 21 and equation 18 is the complete solution of simultaneous differential equation of 1 and 2. So main procedure is, in our question there are two equations are given. In each equations both variable x and y present there, and there is one independent variable t is there. In right hand side is some function of t. So anyway, we delete one variable after making equal one variable, either equal x or equal y. Any one variable keeping equal in equation 1 and 2. Then we get equation 3, 4. Then apply eliminating method in 3 and 4, and one variable is eliminate. Means one variable remove from our question. Either remove x or remove y. Suppose be removing x variable, then there is only y variable. So our equation change in constant differential equation of second order with constant coefficient in y. Then we can find easily solution of y with the help of y equal to cf plus pi, because our equation is known as a linear differential equation with constant coefficient after converting simultaneous linear differential equation. So this is the process to finding solution of a simultaneous linear differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.